Hello, this is Mr. Minnick, helping my students understand the store project demo in this Python class. And here we have some code at Trinket.io, where of course we have our name at the top and what period you're in the documentation header. And then of course we have references and resources at the top of your documentation. For example, where you found certain graphics that you're using that are copyright available. So this example program has some good examples of citations. I might change the format of this in the future, but for now this is a good model. Okay, we always know that we have to import Turtle if you actually want to use Turtle graphics. Welcome. At the top of the program, you need to set up what's called the screen. The screen object, unlike a turtle, is created by typing turtle.screen instead of turtle.turtle. I can name it anything I want, like X, but that would be a horrible name. Screen is my standard example, so I recommend naming it screen. Think of this rectangular area right now where I'm waving my mouse as the screen. You can optionally put in a background graphic. If I had that commented out and clicked run, notice it won't have the background graphic. The orange background.jpg isn't there any longer. So I bring that back into action, re-execute the program, and you see that that graphic is there. All graphics that are used in this project, including this one down here, appetizer.jpg, shrink 40pixels.jpg, they can be found under this icon, and they're all listed right here. Later on, I may show you in this video how to click add image to add a new graphic, but right now I'm not interested in helping you with that task in this video. Back to our source code by clicking main.py. Anytime you're over here, you can click here to get back to your code. Okay, so we have a background graphic. At first, I'm placing the text that you might want at the top of your online store. So a knockoff of Applebee's, Banana Bees, get it? Banana Bees. But instead of naming it Turtle Tina, a more appropriate name for placing this text at the top, I'm just naming it Text Turtle, or just text, or like title text. Any name will be good as long as you start with a lowercase first letter, and if you have two words, capitalize the second word like text. Anyway, I used Text Turtle. It's a perfectly good turtle variable name. So it's just like Tina equals turtle.turtle, only its purpose is, so I hide the turtle. We don't see a little turtle graphic. I set its speed to 0, which makes it go really fast. I pull the pen up so it doesn't draw like a line from 0, 0 up to wherever it starts. And then I do a go to 0, 150. Of course, I designed all this on graph paper first that I'm not showing you here in this video. Of course. It's right here on my desktop. Hear it? That's my piece of graph paper that I was slapping. Anyway, at the point 0, 150. So let's change this 150 to like 250 and re-execute the program. Oh, look! It's so far over here to the right that it's off the screen. Let's change it to like just plain 50 and stop the program and re-execute it by clicking that. And now Banana Bees, the second number is the Y position. So it moved down. Oh, I get it. I'm going to put it back to 150 because I don't want to mess up this good demo program. Okay, the font is Papyrus, and if that's how you pronounce it, I don't know. The font size is 18. Oh, let's experiment with this. Let's change the font size to like 6. Oh, look how tiny it is. That's ridiculous. That would certainly lose points for not being very user-friendly. So back to 18 font size. Let's change this to bold. B-O-L-D. I think in the lecture notes you can learn that you can make text bold. That's considered bold, whereas the word normal there was non-bold. And I'm being clumsy with my mouse. Just give me a second here in this long video. I'm under pressure because a room full of students are watching me. Now, the next little section of the program nicely set off with this green comment that kind of breaks up the program in the sections. We're now placing the images. You know, these two images, we're placing them. So I use a whole different turtle. I could have used Text Turtle. I could have used Tina. But I like different turtles for different jobs. I think it's good style. So Graphic Turtle is being brought into existence. And the whole purpose of Graphic Turtle is to place the graphics. So this is all self-obvious, left 90. And if you have any questions like that, see a student near you or read the comments. Don't bother the teacher because this is like terribly obvious. So this is all code that just sets up the turtle in a position where Graphic Turtle is ready to plop the first image on the screen. Apparently at the position 100,50 is where this graphic drink 40 pixels.jpg is being placed. I believe the point 150 is the top left corner position, precisely if you care. And this stamp is what actually puts it there. So the add shape just puts the graphic kind of in the screen area behind the scenes. Then this line of code takes that graphic and hooks it into the turtle, and then the turtle stamps it. So this would be kind of ridiculous, but you could move the Graphic Turtle to a different location, such as, say, 110,50, and do another stamp, and watch what happens when I run the program now. We'll have two pictures of that graphic, as if it's like a rubber stamper that stamps it twice. See how there are two copies of it there? I moved the one copy 10 pixels over. If I get more dramatic, I could move it down the screen to 150. This would be kind of weird, but watch. I'm now stamping like two copies of it somewhere. So we obviously don't want this in the store project, so I'm going to delete those two test lines of code. So that's kind of what the stamp function does, and the shape and the add shape and this goto. Okay, we need a caption that tells people what this graphic is in case they can't tell the graphic. It looks like the point 87.5 got covered up by the picture. Let's run the program again fresh. I don't see the word drinks there. I'm going to move it down the screen a little bit to say 100, because moving down the screen from 87, would be like, say, 50. Let's run it again and see if oh, look, the drinks, oh, that was the X. I want to move it down the screen, so I think I'm going to do -50 and keep that original 87 there that was there, I believe. And let's see if that looks good. So this assignment's going to be a matter of planning it properly on your graph paper. That's still not close enough, but that would be something for you to upgrade if you were to use this demo program with those numbers in there. Okay, look at this piece of text. Appetizers underneath this graphic. So I'm going to carefully bump it down in the Y direction a little bit, which would mean change that to 30, perhaps 20 pixels lower. Let's run the program with, why is it not showing up there? Oh, I have a question I'm going to ask my students here. I'll be back in a few. Okay, we figured it out during that break. I was changing the position of the appetizer graphic rather than Text Turtle. See, this is Graphic Turtle. This is Text Turtle. If you're using two turtles, make sure that you're changing the goto correctly. So by changing its Y location to say -30, or -33 will work, I think. That will move this caption down to where I can now see it. I would take off points if I were grading this right now, just for the record, because that's not lined up with that. And neither are these two lined up. Boy, there's a lot of room for improvement here. Okay, the next little section of the program. Constants. When a boss or the owner of the company decides to make a price change to, like, say, the menu of that restaurant, he or she would just come in and change like the number that you see after the right side of the equal symbol there on price per drink. Then every place lower where price per drink shows up, like right here, and perhaps many other places, That now changes to whatever new number I plugged in up here. So right now it's 190, but I could change it to like $2 because you know how prices go up. We don't like to use the number 190 down in the actual code itself. This is bad style. That's called a magic number. That's hard for other coders to find, especially when they're in a hurry. So it's good to use what's called a constant that's in all uppercase letters, and when it's more than one word, we use an underscore to separate the words. You cannot use spaces in the name of a variable or a constant. That's illegal to have spaces in there. And this would look bad. Agree with me, of course. Price per drink, that just, people might not see that and understand it's 3 words, especially when they're in a hurry. So we use underscores with constants. Now don't put a $sign in front of this because $signs aren't allowed. And if it's a number in the thousands, you can't put a comma. Commas are not allowed either in numbers that are in the thousands. Nobody would charge $1,234 for a drink. So let's put that back to 1.9. Maybe in the future, like after inflation hits. Okay, this section of the program, something called variables. Variables are kind of like constants, only they're bound to change. Get it? Vary. So a constant never changes. It stays at 190 or 899 for the rest of the code program. But a variable could change. It starts at 0 typically, like when you were born, you started at 0. But then when you hit your first birthday party, they added 1 to your age. So it's kind of like age equals 0. Then eventually later in the code it becomes 1, then 2. And as far as I know, nobody's like figured out how to go backwards in age yet. Fountain of youth, you know. But anyway, in this program, total cost starts at 0. All variables and all constants, when they first appear in a program at the top, they should have a comment that explains their purpose in the program over here, nicely vertically aligned with hashtags like that. Now, you don't have to use complete sentences, but do spell it correctly and make a nice little phrase that explains the purpose of that variable. Okay, your first example of what's called a function in this course. Look how functions can like blinds on a window. Look, down, up. The blind is down, the blind is up. Let's look at the body of the function. A function always starts with a DEF keyword. The name of the function here is called getUserInput. The body of the function is the code that's indented. If you indent a little bit too far with one of the lines of code and not the same distance with the other line of code, it gives you an error. Watch when I try to run the program now. It gives me an error. I just did something here by accident. It gives me an error down there that my indentation levels, you can't see this in the video, so let me move it down. See how my error showed up? Because that indentation was wrong. That return has to be lined up, the R has to be lined up exactly with the N. Now let's study this function. Kind of like the f of x, well, this is like the x. Prompt is called an argument or a parameter, and we'll see what that does later. Just know that this works for now. Format number, it just works. That's another function because it starts with DEF, and just know that it works. Now let's get to the interesting part of the program. A user comes along and decides to run this program, and he or she enters how many sneakers they want. What? That makes no sense. This program sells drinks. Let's change that to drinks. Now I'm going to run the program and show you what it does over here interaction-wise. Enter a number of drinks, and let's just buy 1. I hit the enter key on the keyboard, and now it says, oh, how many appetizers you want to buy? See this next line of code? Enter number of appetizers. So over here, I type 1 for that as well, keeping it simple. I'm pressing the enter key on the keyboard, and now the program tells me the total cost. So let's see how it figured out the total cost. Well, after getting the user input, the program did computations. You know how algebra works in math class? Front order of operations and all that math stuff with a calculator, or sometimes you can do mental math. Num drinks, if you remember, was 1. Price per drink, I forget. Let's go up here. Price per drink is $1.90. So 1 times 190 is 190. Hold that on your left hand, and now take 1 for the number of appetizers I bought, times the price per appetizer, which I think was $8.99. Yep, $8.99. Everybody knows that 1 times $8.99 simplifies to $8.99. So you have that subtotal in your right hand. The left hand was 190. The right hand is 890. Some people can do that in their head. 1098 is what I just got in my head. I didn't need a calculator for that. 1098, 1098. 1098 is what gets stored in this variable x or z or whatever. Oh no, it's total cost. The name of the variable is total cost. So 1098. Now the round function that's built into Python rounds it to however many decimal places you have there. Let's put like 20 in and see what happens if we want to round it to the nearest 20 decimal places. And that's the variable that I'm rounding using the round function. And whatever that final number simplifies to, the rounded answer, gets stored back into the variable total cost. And for now, I'm glossing over what this DEF function format number does. So right now with the 20 there, let's run the program and see what happens if I type 1 for drinks and 1 for appetizers over here. The program stopped for some reason. Okay, here goes. Ready? 1. Oh, because number format, because of this 0.2, that also causes it to stop after 2 decimal places. I don't want to go over, that's like more advanced. Just know that that always works. Anyway, that backfired on me. The 20 there didn't really help. Just keep it as a 2. Oh, and we're not done yet. Look at the rest of this program to analyze in about 2 minutes here. Text turtles, pen goes up, goes to the location 50, 100, negative 50, negative 100, obviously. And then we take the 1089 total cost, and we're turning it into what's called a string. A string is like your zip code, 19610. A number is like 19,610. Unfortunately, Python is complicated in that you can't just do this write command and have a number print out unless you first change it to a string using the string function. So without that line of code there, if I hashtag this out, the program would probably crash. Let's see here. Let's one more time buy 1 drink and 1 appetizer. Oh, darn it, I'm a liar. It worked anyway, but just trust me, that's good style to have that str in there. So let's pretend that that actually would have caused an error. Okay, at the end of an app or an application, a program, you should always tell the turtles they're done. So the done command just tells the turtle it's finished. If you don't have it there, it usually doesn't cause a problem, but it's good to be safe. And we've already figured this out. I have that in from last year. Somebody did figure out how to do all this. I have to like look it up. But if you figure it out, just email me at this address. In the meantime, have fun remixing and upgrading this project according to whatever the store project specs are. And now I would appreciate an applause.